Alright, continuing on atomic trends. This video is going to cover ionization energy, IE for short, and electronegativity, E-neg for short. Sounds all kind of weird. Anyway, ionization energy. Definition: the energy necessary to pull off an electron. Emphasis on pull off. I know with the word ionization energy you think make an ion. Oh, two types of ions. No. We are pulling off an electron. Excuse me. Our trend, as we move across a period, my ionization energy increases. Why? Because, as you might expect, bigger magnet. I am increasing my number of protons as I move across the period. Excuse me while I get a drink of water. As I have that stronger magnet, I am better able to hold on to the electrons that I already have. Also, if you think about moving across the table, whoa, zoomed in. As we move from positive ions to negative ions, as I move into my negative ions, I'm getting closer and closer to a full octet, which means the last thing that I want to do is lose electrons. In fact, I want to gain more, which means I am going to hang on to the electrons I already have with a fiery will. As we go down a group, my ionization energy decreases. Why? Our key phrase, more rings. As we go down the group, each row adds a new ring, which makes the electrons further away from the nucleus's power. Each of these rings that is between the nucleus and those outermost electrons is called shielding. They shield the outermost electrons from the power of the nucleus. One other thing that I need to mention about ionization energy. When I pull off the first electron, that is the first ionization energy. Second electron, second ionization energy. So this trend holds true only for first ionization energy. As soon as you get to second ionization energy, you really need to start thinking about the electron configuration. What happened since I lost that first electron? Am I at a full octet now? Am I half full? Did I make a negative ion where this thing usually forms positives? Whatever the case may be. But as soon as you start moving into second ionization energy, draw the config. Figure it out using the configuration. For example, if we wanted to know who has a higher second ionization energy, sodium or magnesium, let's look at their configs. 2s2, 2p6, 3s1. So, these guys are right next door to each other. Sodium and magnesium. So, the trend said that as I went across, my ionization energy increased. So, that means that magnesium has a higher first ionization energy. He has more protons, better able to hold on to the electrons the same distance away. Third ring away. Bigger magnet, better hold. But I don't want to know about the first ionization energy. I want to know about the second. So after I yank off one electron, so this electron, gone. One of these electrons, gone. So second ionization energy, I'm going to pull off one more electron. This guy now has a full octet. Look at that, 8 electrons. He doesn't want to lose anymore. He wants to keep the ones he got, which means I'm going to have to yank super duper extra special hard to get off that second electron. He doesn't want to let go of it. Magnesium, on the other hand, is now at a half full orbital. He doesn't really want one electron. He's going to get rid of it. Magnesium usually takes a 2+ charge anyway, so he doesn't really want this electron. Sodium, full octet. Sodium has the higher second ionization energy, and all that we figured out just from looking at the configuration. So look at the bloody config. One last note, the bell's going to ring here in my school, so I'm going to make this video short and sweet. I forgot to mention on ionic radius, there is a slight difference between atomic radius and ionic radius in the fact that ionic radius has two sections, positive, negative. Positive ions follow that trend, shrinking as we go across. As soon as we hit the negative ions here at the zigzaggy line, all of a sudden we jump to larger ions because negatives are bigger, remember? And then continue our trend. So think of this zigzaggy line as a hiccup in your trend. All the positives follow that same trend of decreasing as we go across. All the negatives follow that trend of decreasing as we move across. But at this zigzaggy line, there is a break between the positives and the negatives. Atomic radius, same thing all the way across. So, short video so you don't have to listen to the annoying bell ring. And the next video, we'll talk about electronegativity.